My name is Bob Lee. I created this framework called Juice, which is what I'm going to tell you about. Juice supports dependency injection for Java, and if you don't know what that is, that's okay. I'm going to explain what dependency injection is. And if you do know what dependency injection is, that's okay too, because it's kind of fun to take a step back and examine what we know and really identify how it helps you. So the whole reason we're here, the question is, what can dependency injection do for me? And the focus here is I'm going to show you how it can make testing easier, particularly unit testing. I'm going to show you how it can help you decouple your code more. I originally built it for Google AdWords, which is one of Google's biggest in every way products and most innovative products. And we use it currently, and we still use Juice to break it down into separate modules. I'm going to show you how dependency injection, and particularly Juice, can help you write less boilerplate code. You probably noticed, especially with Java, you write this same or very similar code over and over and over again. I mean, we do it so often, we write these same patterns so often that we tend to not even realize we're doing it. And I guess kind of the overarching theme here is going to be how to make your code more maintainable. And when you have like a really big application with hundreds of developers and millions of lines of code, this is of the utmost importance, especially if it's an application that's going to stick around for a while. You know, and you're editing code that's 5 years old, 10 years old. The way I'm going to structure this talk is I'm going to start off with a very simple example, and I'm going to compare dependency injection to patterns you probably already know, like the factory pattern. And I'm going to show you how to do dependency injection by hand, because you don't need a framework to do dependency injection. You can, it's just really like a pattern, or more appropriately an idiom that you can follow. And then I'm going to show you what the same examples look like with Juice, and show you exactly where Juice benefits you. Let's just look at a high-level design for our example. This is a really stupid simple example. It's almost unbelievably simple, but it's going to kind of illustrate what we're doing here. Kind of the central actor in our example is going to be this client class. And client is going to depend on an interface named service, and we're going to have one implementation of service called service impl. That's what you always call it. And then we're going to have a test against client. And we're going to try and like mock out service and examine different ways of doing that. So, as I said, we're going to follow 3 approaches for implementing this example. We're going to use the factory pattern. Everybody familiar with the Gang of 4 factory pattern? Wave your hands if you are. Okay, and for those of you that aren't, then we'll be able to pick it up pretty quickly. We're going to examine dependency injection by hand. This is just kind of changing up the factory pattern a little bit and building on it. And then we're going to look at dependency injection with Juice. And then after that, I'll give you a quick introduction to Juice so that you can get started. There's going to be one variable across these 3 different approaches. One thing's going to change, and that's going to be how our client class gets access to a service. And then there's going to be a few things that are going to stay the same. And that's going to be our service interface, which I made it as simple as possible. It's a simple interface with one method named Go, and we have a single implementation, which we don't really care what the actual implementation of this method is. Well, let's just assume that it's something expensive, like we're accessing a remote server or something like that. Something that we don't want to do during a unit test. Maybe we're charging a credit card, who knows. And then, in addition to that, we have a mock service. How many of you use mocks for unit testing? Anybody? 1 person? 3? Okay, well, we're going to learn some more then. So this is just a mock implementation of our service interface. And this is something that we can swap in when we're testing. Because, as I said, if our service was billing a credit card, we don't want to do that when we're just testing our client code. This interface, just all it does is keeps track of whether we called the service or not. It couldn't be any simpler. So let's start off with approach number 1. We're going to look at the factory pattern. We'll start by looking at the client. So our client code, it needs to get access to a service, and then it's just going to call a method on it. That's all our client code's going to do. So with the factory pattern, our client uses a factory to get access to the service. It just calls a static method on our service factory class and gets the service and then calls the method on service. Everybody's probably seen code like this hundreds of times before. Now, what's kind of interesting and what sets this example apart is our actual factory implementation. I'm sure you've all seen code like this before. I just used a simple singleton here, but we could make this a lot more complex. It could be getting an object off the HTTP session or off a thread local, or using like a service locator or whatnot. And we have the instance that we create statically, and then we have this like static getter method. This is our factory method where clients can get access to the service. And then, because we all like to write unit tests, we have to provide clients some way to swap in an alternate implementation of service. So we have yet another method down here that lets them pass in a service. And you write this same code for every time you want to make kind of decouple a client from your implementation. So, and by that I mean, so this just note that this just returns service, which is just our interface. So the client doesn't know anything about our actual implementation, right? Not directly anyway. So if we're going to write a unit test against client now, and we're using the factory-based approach, let's look at what that unit test will look like. We need to, the first thing we do, I've highlighted the important code right here in the middle, but you'll also notice up here at the top, we get the existing service instance and keep track of that. Then we swap in our mock implementation of the service, and we just pass it off to the factory. Then we test our client and make sure that everything went through. See, we test that the assert true. We check against the mock and make sure it was called by the client. And then at the end, we have to take care to swap back in the previous implementation of service at the end of the test method. And does anybody know why we have to do that? Does anybody? So how many of you have run your unit tests once and they passed, and then you run your unit tests again in a different order and they fail? This is something that I run into a lot, or used to run into a lot before I started using Choose. And the idea is that if we didn't take care and swap back in this other instance, and we just left our mock instance in, then another test might pick up that mock instance and fail based on whether this test ran before or this test ran after. And it gets really annoying because this is just like one dependency, but when you have multiple dependencies, you have all this boilerplate code in your unit tests, and you have to take care to do this setup and then the teardown and the finally method. And it really adds friction to unit tests, and people just end up not writing them. So I just wanted to point out a couple things about these examples we just looked at. I just talked about the fact that the unit test had to pass in the mock factory and clean up afterwards. One thing that kind of strikes me as interesting about this is when we're writing this unit test, how do we know that client depends on service? The only way we can know that is by looking at the service implementation. And you have to dig through the service implementation, or the client implementation, then you have to dig through the things that it depends on, the things that it depends on, to find out everything that you have to mock in. And that's really annoying. Another thing you might notice is that using client, if we wanted to use client with two different service implementations in the same application, that's going to be tricky right now, right? Because get service will probably always return the same implementation. If we have two threads calling like two clients at the same time, how do we make them both get the right service implementations? It's kind of a pain. The thing that annoys me the most is the fact that you have to write this same factory code over and over and over. I mean, you can almost generate it, right? And then people tend to do it in inconsistent ways. Like sometimes I'll have a static getter method. Sometimes I'll have to look up my factory through another static factory. Sometimes I'll use a service locator. Sometimes I'll use this other service locator over here. Sometimes I'll use the JNDI initial context, for those of you that have written EJBs before. And then one more thing that I want to kind of note here is, one final thing, is that client really, the way we've implemented this factory, client still has a compile time dependency on service impl, because client depends on service factory, and service factory depends on service impl. And this was one of the problems that I ran into with some bigger applications that I worked on. It's you get so many lines, and if you have millions and millions of lines of code, it takes forever to compile, it takes forever for your server to start up. It'd be really nice to be able to just check out like a little piece, maybe like 1/10 of your application, and just compile and test that one piece, and then integrate it, do the slower integration later on. And we can kind of mitigate this using like the service locator pattern or something like that. You know, maybe specify your class as a system property and dynamically find it at runtime, but you also, that also leads to inconsistency. People do that in different ways, and it also, it lacks startup checking. So if you're loading a class based on a system property at runtime, it doesn't blow up until you go to actually use it, which is kind of a pain. So you really want to find out about that stuff as soon as possible, like compile time. So let's move on to approach number 2. I'm going to show you how to do dependency injection by hand and kind of avoid some of these problems. So the main thing that changes, as I said, the thing that's going to change from example to example is how client gets access to service. If you remember in our factory example, client called out to a factory to get an instance of service. Well, now we're going to change client so that you have to pass an instance of service in. Client doesn't care where it comes from. Client doesn't care if service is an interface or a class. Client doesn't care about how service gets created. It doesn't care about anything. All client knows is that you pass it the instance of service that you want to use, and it does what it's supposed to do with it. In this case, it calls go on the service. So let's take a quick look back at our factory test again. You remember I highlighted the lines that the important lines, and then these kind of non-highlighted lines, the lines where the code where we get the old service and then we pass on a mock instance to the factory and then reset the old one. This is all kind of like noise around the test. Well, with this new structure for client, we can simplify our test considerably. As you can see, all that's left, we kind of melted all that away, and now all that's left is this nice clean code that it's only the code we care about. So you new up a mock service, you just pass it into client. We don't have to worry about a factory at all. And you call client, and then you test that client did the right thing. It doesn't get much simpler than that. And so, I mean, we just destroyed like half of our unit test code. So how do we now, how do we get that instance of service into client? Well, if we're doing dependency injection by hand, the way we do that is, in this case, we have to introduce a new factory. We're going to introduce a client factory. Yes, so we're still using the factory pattern, just a slight variation of it. And what we've done is we've moved that dependency on how we get service into the factory layer. So we have like these nice clean domain, unit testable domain objects on like the lower layer. And then one layer up, we have this kind of like layer of factories that all depend on each other. And so you could have another set of factories too, another independent set of factories that work against those same nice clean objects, nice clean pojos. So let's kind of compare doing dependency injection by hand to the factory approach. So in our test, we were able to just pass the mock directly to client. And kind of one of the things I like about that is there's no middleman anymore. You don't have this kind of third-party service factory that you have to deal with. It's just the mock service and the client. Another thing I like is that you can't create client without providing a service. In the factory-based approach, if you'll remember, we had to like write our test, and then we had to realize that client is accessing this service factory somewhere deep down in the implementation. Well, in this case, it's very explicit. You can't even new up a client without providing it a service. So we don't have to worry so much about client like accessing remote URLs or accessing slow remote services in the middle of our unit tests. We can easily reuse client with in different contexts. All we have to do is new it up and pass it a different service implementation. As I said, we can have multiple sets of factories that all create clients. Client no longer depends on service impl and compile time. This is kind of an important note. As I said, you have that kind of like layer now. You have the client, which is nice and clean and doesn't depend on anything except for interfaces. And you can go check that out and compile it separately. And then you can have like the layer above that with the factories, which you can compile separately. And you can have different sets of factories, and you can reuse client in different applications pretty easily. Kind of the downside to this is that you have to write a little bit more factory code, which is a huge pain. And the reason this is such a huge pain is because whenever I'm writing this initial code, now I have to make the decision up front about how much decoupling I want, how much flexibility I need. Because on the one hand, I could just new up service impl, write my client, and that's the simplest code possible. On the other hand, I could go to the trouble of writing all these factories and wiring everything together, but that's a huge pain. I like the flexibility, but I don't like all the work that it entails. So that brings us to approach number 3, which is dependency injection using Guice. And as we'll see, Guice is going to kind of melt away all these factories. We're not going to have to write this manual factory code anymore. We're not going to have to write the same lazy loading code over and over again. For those of you that have written web applications, I mean, I don't know how many times you've written code to access the HTTP session and like check if an object's there. If it's not, create it, put it on. You know all that. And that's what I mean by scopes. So we don't have to write custom scoping code over and over again. Another problem that Guice is going to solve is this need for more upfront type checking. So when we have factories buried down in our code and we can't see the dependencies, well, we don't know that we're missing a dependency until we go to run that code and it blows up. Well, I prefer to be able to just kick on, start up my application, and have it tell me right away if it's missing a dependency. That way I don't go into production and start giving clients exceptions, right? We also want more flexibility, so we don't want to have to make everything static, but we still want the upfront checking. We want to be able to dynamically specify like which database driver we use and whatnot. And kind of the thing that I like most about the framework approach to dependency injection is it makes it easy to do the right thing. Even if you have somebody on your team that doesn't entirely understand dependency injection, this kind of pushes them in the right direction and makes them write code the right way. With doing dependency injection by hand, I think you'll all agree with me that that code was a little complicated, and sometimes it's easier to it would just be easier to call. The easier thing to do would be to call service factory directly from client. Well, this makes it easy to do the right thing and have service passed into client. So instead of factories, instead of the service factory, instead of the client factory, Guice has this notion of a module. And this is kind of Guice's configuration mechanism. And it uses what we call a domain-specific language. How many people have heard that term before? Okay, so a domain-specific language is where you try and write kind of a natural-sounding language using a Java API. So in this case, as you can see, Guice, we want to tell Guice that whenever it needs an instance of service, we want it to use service impl. And the way we do that is we just say bind service to service impl. So we're creating a binding from the interface service to the implementation service impl. And this is one of the really cool things that Guice can do. You'll see down here at the bottom, it says in scopes.singleton. So you can tell it not only to bind to an implementation, but you can also specify the scope that you want it to bind it in. By default, Guice uses no scope. It's kind of like a meta scope. And that's where it'll create a new object every time. So if we didn't say anything here, it would pass it a new instance of service impl every time. But in this case, we're saying we want it to be an effective singleton, in which case Guice says, oh, so you only want one instance of service impl. We'll just pass in that same instance every time. And kind of the really cool thing about it is these scopes are completely pluggable. You can implement your own. As I'll show you later, Guice comes with scopes for doing web development. So you have like the request scope and the session scope. That was one of the big reasons I built it. Is I got so tired of accessing the HTTP session and things not being type safe and all that. Guice makes that really clean. All you do is say this object's in the session and it'll put it on the session for you. So the second change we have, so we replaced our factories with module. The second change we have is to client. Our client looks very much like the dependency injection by hand version. We only have to make one little change, and that is we use this annotation. It's called @inject. So how many people have used annotations with Java? Is anybody on Java 5? So a reasonable number of you. For those of you that don't know, annotations were added in Java 5, and they just allow you to attach metadata, which is just kind of like extra information that client, and then test your assertions. So, what are our conclusions? Even for this stupid simple little example, even for this little example, Guice required much less code, 20% less code overall. I mean, that's a pretty good save. We knocked out 1/5 of the code on a little example like this. But what's more interesting to me is that where Guice really shines is as we use service in more places. Now, every time we need a service in our classes, we just put @inject and take a service. And Juice can inject constructors, methods, or fields. So it doesn't get much simpler than that. So the more you use service, the more Juice benefits you. And we'll have more startup checks. This is kind of one of the places where Juice really shines, and one of the places where I took special care. As I said, we have a really big application with lots of dependencies, and we wire it together in many different ways. And so that makes having kind of load time kind of type checking all the more important. And Juice always, if you're missing a dependency, Juice will blow up at startup, and it'll even tell you the line number where you're missing a dependency. I mentioned the declarative scopes, so you don't have to write this lazy loading code anymore. You don't have to write code to access arbitrary maps. You can implement your own scopes and just tell Juice to use them. More flexibility, so you can, one of the things that I really like, so one of the features of Juice is the way we like to handle configuration is, I like properties files still, I only use XML if, my data is a little more complex. Like Juice can just slurp in an entire properties file and create bindings for all your properties, and then get automatically, and then you can inject those anywhere you need them in your code. So you don't have to call out to like some factory for your properties either. And then in your unit test, you just pass in like the literal values, so you don't have to deal with swapping in different properties implementations. And then the biggest win here, besides the fact that it helps you do the right thing, is it makes the upfront design easier. We no longer have to make that upfront decision, should I call the constructor directly or should I write all this factory code? Well, now it's almost just as easy just to have your thing injected in. It's almost as easy to have it injected in as it is to new it up yourself. It's actually even easier because if you have it injected in, then Juice can further inject it. So now that we've kind of seen the example, and you're obviously, I can tell by the looks on your faces, you're all sold on Juice. I'm going to tell you how you can get started with it. So my partner on the project, Kevin B., likes to say objects have to be in the club to be injected. So this is the question, how do my objects get injected? And there's a really simple answer, just you have to let Juice create your objects. And that can happen in a couple ways. Either you have to explicitly ask Juice to create your object, or Juice has to create that object in response to an injection request. So it's like creating service impl to inject in the client. Well, it's creating service impl, so it can also be service impl is also injected. And I refer to this idea as bootstrapping. With the idea of bootstrapping is that I don't want to always explicitly ask Juice for my objects. If I did that, then I would have a service locator, not dependency injection. So the idea is I just ask Juice for one root object. This could be like my web server or just kind of like my main class. And then Juice will inject dependencies into that class. And then as it creates those objects so it can inject them into that class, then it injects those too with further dependencies. It's recursive. So you end up with your entire object graph and everything's nicely injected, but you only had to ask Juice for one object. And then, so you just have this kind of little entry point. This should be, in this example, if we were writing a command line application or something like that. So everybody's familiar with public static void main, your entry point. Well, this is exactly all. This is all it would take to wire up our simple example using Juice. The first thing you do is you create an injector. We call it an injector. Some other frameworks would call this a container, but Juice is really simple. All it does is it injects your classes. So you create an injector and you pass it that module. I repeated it down here. This was the module we saw at the beginning. And remember, it just binds service to service impl. We just tell Juice to do that. So you pass Juice that module. And then on the next line, so we have this injector now, you ask Juice for an instance of client. And to do that, you say injector.getInstance of client.class. And it returns a client. And then you can use your client instance, and service has been injected into it. Juice took care of all that. So maybe kind of one interesting thing that you'll note here, we didn't explicitly create a binding for client. Client is a concrete injectable class, and if that's the case, then you don't have to create an explicit binding for it, which is kind of nice. You only have to create an explicit binding when you need to tell Juice which implementation to use for a particular interface. Okay, so let's say we want to add a new dependency to our example, and in this case, we're going to give service email capabilities. And so all we have to do in this case, I'm going to use field injection here. As I mentioned, Juice supports constructor, method, or field injection. It can call constructors and methods with any number of arguments. So if we want to add a new dependency to service, all we do is we say @inject emailer, and then we have our emailer field. And then now, when Juice creates an instance of service info, it'll inject an instance of emailer into it. For our purposes, we'll just say emailer is a little concrete class. I just have the kind of boilerplate, or the little template down here for that class. So, and it's a concrete class, so Juice can just create it. And then so whenever we call our service, so we can do our former expensive stuff, and then we can just, in this case, we can just send off a confirmation at the end, an email confirmation, and tell Juice that we wanted to send that off. And if we were to write a test against service, we could pass in a mock version of emailer, so that you don't have to really send an email every time you run your unit tests. Okay, and just one little thing to point out is that service is in the club, as Kevin would say, which means that emailer will get injected into it because we're letting Juice create it. The surefire way to know that an object's not in the club is if you're newing it up, if you have new in your code. So I guess kind of the at least for dependencies that you want to be abstract, new is bad now. Okay, so let's say things get a little more complicated. Having one implementation for an interface works probably 90–95% of the time, but every once in a while we're going to have multiple implementations of an interface in the same application, right? So Juice handles this in a kind of innovative way. We use something called a binding annotation to differentiate which ones we want. So let's say we have a different type, we introduce a different type of emailer into our application. We have our old emailer, which we were just using, but we also have a transactional emailer. And the transactional emailer has to run in a transaction. And why the heck would you want a transactional emailer? Well, let's say that we're checking out a shopping cart or something like that, where the customer is buying something, and we want to send a confirmation email send a receipt to the user, and if that receipt doesn't get sent, then we don't want to charge the user's credit card. And if that receipt, if the user's credit card doesn't get charged for some reason, we don't want to send them a receipt and let them think that they bought it. So in this case, we know in service info that we want a transactional emailer, and the way you do that with Juice is in addition to the type, we now have this annotation, and in this case, we'll just call it @transactional. So now we say @inject transactional emailer. It's as simple as that. And then, so how do we tell Juice what to use whenever it sees inject transactional? We just add another line to our module down here. Can everybody see this? So it's using kind of like this kind of nice language again. We say bind emailer.class annotated with transactional to transactional emailer. And transactional emailer is our transactional implementation of emailer. But the client doesn't need to know that. They just know that they need a transactional emailer. They don't care what implementation we use. Just one more thing I wanted to kind of point out in regard to binding annotations. You create these yourselves. You write these yourself. But you don't have to create a whole bunch of them. We don't have to create a binding annotation every time we have two different implementations. These binding annotations can be really general, like this one, transactional. We could use transactional with service. We could use it with data source, right? You could use it with multiple different dependencies. So these are reusable. So sometimes things get even more complicated. Sometimes we're dealing with third-party classes, or for security reasons, we can't let Juice create our objects. Like, we can't apply @inject to that class. We don't want it to be tied to Juice. And Juice does provide a way of handling this. We have an interface in Juice called provider. And provider is just a simple interface with a get method. And so instead of saying bind emailer to transactional emailer.class, we can tell Juice to bind emailer to our provider. And then our provider can take care of creating the objects manually. So in this case, we create a new emailer and just return it. And Juice, so every time Juice needs an instance of emailer, it'll call our provider, which, as you can see, here's just a little simple anonymous center class. We just did it right in line. And kind of the interesting thing you'll see here is that providers themselves are also injectable. So we don't have to break out of this nice dependency injected world. You can inject variables into your provider, and in this case, we're injecting a property named email host, and then we can just pass those dependencies. We can just forward them on directly to our implementation. And one more interesting thing is that scopes can apply to providers as well as anything else. So you can just write your simple provider that returns a new object every time, and then you can tell Juice, hey, just call me once, make this a singleton. Another thing that comes in handy is sometimes you don't want all of your objects to be created eagerly. So if we just had everything directly injected in and injected in and injected in into one big object graph, we'd load all our objects at once. Well, sometimes we need multiple instances of an object. How do we tell Juice that we need more than one? Sometimes we don't want to create an object at all. Say, sometimes we need an instance of foo, sometimes we need an instance of bar, but they're expensive to create. We only need one or the other. Well, the way you handle that in Juice is you also use the provider interface, but in this case, Juice is giving you the provider. So for any type, regardless of the implementation, for any type that you have bound in Juice, you can also inject a provider of that type. So we can inject a provider of service. In this case, we can inject a provider of money. And you can call that provider whenever you want. And Juice will kind of resolve that dependency whenever you call a provider. And so, like I said, that comes in handy when you don't want to call, when you may not want to get that dependency necessarily, when you need multiple instances of that dependency. And it also comes in handy in one more case, is when you need to kind of transcend scopes. And by that I mean, let's say I have a singleton and I want to access a request scoped object, like an HTTP request scoped object. Well, if I just inject that request scoped object into singleton, that won't work, right? Because it's going to be injected once for the whole lifetime of the application, but I have lots of requests. Well, as a way around that, I can inject a provider of that request scoped object into the singleton and then just call it every time, and Juice will automatically get it off the request for me. Kind of getting to the end here, I just want to, one of the things I mentioned, Juice supports constructor, method, and field injection. I just wanted to give you some rules of thumb for when to use which versions. These are the rules that I follow. The first thing is, I always prefer constructor injection. You know, I like to make things immutable. I like to make all my fields final. I like to know that my objects are always in a good state, and this serves a lot of purposes. It makes concurrency easier. It makes testing easier because it makes maintaining your code easier. That's the most important part, because I can look at this field and see that it's final and know that it never changes. And my compiler will tell me if I try and change it. But sometimes constructor injection doesn't work. Some examples of cases are, I've been known to provide a class that other people can subclass and say I don't want them to know I depend on something, or I don't want them to have to know, because if I use constructor injection and I take a dependency of my constructor and then they extend me, well, they have to pass me that dependency, right? You always have to call super when you extend a class. You always have to call super from the constructor. So that's kind of a bait if you don't want them to know about your dependencies and you don't want them to have to change every time you add a dependency. So that's where method injection can come in handy. Another case is where, as if Juice can't create your objects. As I showed you kind of the custom providers before, like where you can create your objects manually. Well, you obviously can't use constructor injection because we already ran the constructor, but you can still use method injection and ask Juice to inject your methods on your existing object. This is useful for like third-party frameworks and that sort of thing, where you don't have control. how your objects get created. And finally, the only times that you should really use field injection are when you don't care about testing. So like if you're just doing like a little simple inline provider and you don't care about being able to unit test it like we did before. And then for slides for your talk because it makes your code shorter. So as we're getting to the end here, I just wanted to give you guys some more information on some other features that Guice provides that we haven't really touched on, which you can kind of investigate if you're interested in trying out Guice. I mentioned the custom scopes already. Guice already provides the servlet scopes. Other scopes that you might use, or that you might create, could be like, you could have like a transaction scope, and you could use that to cache your entities just for the scope of that transaction. And if you start a new transaction, well, you don't want any of that stale data to stick around. Well, if you have a transaction scope, it'll automatically go away. One of the things that I really like is that Guice supports type conversions for constants. I mentioned before that Guice can just pull in like a whole properties file. Well, not only can it pull in a whole properties file, but it can also convert the types of those properties for you to like numbers, classes, enums. That's kind of a really cool one. And it'll fail at startup if it can't do that. And it'll only convert it those values once at startup, which is kind of a nice, it's kind of a nice feature as opposed to constantly converting those properties over and over again at runtime, which is kind of a pain. And it's typically like hard to cache those. One of the really interesting features is how many people are familiar with AOP? Couple people. So this is this idea that you have cross-cutting concerns. And by that I mean you have this kind of similar code that you repeat over and over again throughout your code. It could be like logging code, or it could be code to start and stop the transaction. Well, Guice lets you abstract that stuff out using this feature called method interceptors. And so for a common use case of this would be if you've used EJB before, you can you could just apply if you had a transaction interceptor mapped with Guice, you can just apply @transactional to your methods, and Guice would automatically start and stop a transaction during that method. One of the other interesting features that we introduced in Guice is this idea of development stages. So you can tell Guice it has like a fixed set of development stages, and right now it's development and production. And the idea here is that you want your application to behave differently depending on what stage you're in. Like during development, you want to lazy load all your singletons, right? Because you only want to exercise the parts of your application that you're working on and that you're actually testing. Otherwise, you gotta wait like half an hour for your server to start. But on the other hand, in production, you want everything to be created at startup. You want to make sure everything's okay. You want everything to perform really fast whenever your clients start hitting your server. So if you put Guice in production mode, it'll eagerly create all your singletons and have them ready to go. And Guice also provides you with the stage. So in your modules or whatever, you can write custom code based on what stage you're in. Another feature it supports, which I don't even know if is worth mentioning, some people like optional injection. If Guice can't find, this just will allow me to emphasize the point that if Guice can't satisfy a dependency, it fails fast. Like it tells you it won't even start your application. But you can also, you can kind of loosen that on a case-by-case basis, say, well, this is optional. If we don't have it, then I'm fine. You know, I can find my own default implementation. Guice also comes with integration with a lot of technologies that you may already be familiar with, like JNDI and the Spring framework. There's a lot of overlap between Guice and Spring, but Guice plays very nicely with it. JMX, has anybody tried JMX before? So JMX stands for Java Management Extensions, and it's kind of like a monitoring framework that's really nice. I think it was added in Java 4, and so you can use these standard tools to connect to your JVM and see like the memory usage, track the garbage collection and all that stuff, and you could expose your own admin consoles using JMX. Well, Guice comes out of the box with JMX support, so you can just connect to your application with a standard JMX client and see in a nice GUI all of your bindings and kind of navigate down by type or by binding annotation. Guice also comes with integration with struts too. How many people have used struts before? Come on, don't be shy. Raise your hands if you use struts. We all have. Juice, I'm also a struts 2 committer. And that's actually where a lot of my ideas for Juice came from, was in redesigning the API for struts, which is still a work in progress. I got to finish up some stuff in Juice and then go back to that. But even right now, Juice comes with a struts 2 plugin that, do you remember how I mentioned this idea of bootstrapping? It's how you have to have those root objects that get injected, and then everything else can get injected. Well, in struts 2, if you use the plugin, your actions, your web actions are the bootstrapped objects. They're the root objects. So whereas normally with struts 2, your actions would have no argument constructors, well, now you can take your dependencies in your action constructors. So if you use struts 2 with Juice, you don't even have to ever worry about the injector or anything. You just create your bindings, say bind service to service impl, bind foo to foo impl, and take those things in your actions. It's very, very clean, very simple. So just kind of a little preview of some upcoming features in Juice. Some of you might agree that that custom provider implementation was a little verbose. It gets to be kind of a pain to write those. So we're coming up with a new feature we call provider methods. So instead of writing a full-blown class, you can just write one class with a bunch of methods that provide objects. And also one of the things is right now you have to make this decision between Juice injecting your object or you creating it manually. Well, in the future we're going to kind of support a hybrid. So Juice can give you an already injected instance, and then you can do some more initialization on it, and then you can provide it. This third feature, which is going to be really, sounds kind of vague, construction listeners, but the idea is we're going to give you a hook into Juice where you can kind of run your own code after Juice creates your objects. And this will enable a whole slew of new things to be built on top of Juice. Like you can write your own kind of like life cycle things, like you can call an initialize, write a listener that calls an initialize method on your class. You can write your own custom injection policies. So you could do stuff, if you've seen EJB3 before, it has kind of like some domain-specific injection. It uses this @resource annotation to inject EJB resources. You could implement that on top of Juice now. And then I think for version 2050, we're going to implement artificial intelligence in Juice and have it automatically read your mind and figure out what bindings you want. Does anybody have any questions? You guys can just, you know the drill. You can feel free to write them down and pass them up, or if not, then we're here.
I want to know. I want to know if the constraints applied to the class, which you can make some construction injection and the method injection. Is there any difference? You know, the construction injection, you can do that because you act as some factory thing. But how do you do that for method injection?
What do you? I'm sorry. Can you repeat that last part of the question?
The last part is how to do method injection.
How does Juice do method injection?
Yeah.
So it just does the field and method injection using reflection right after it constructs your object. So it does it. So it constructs your object and then injects the fields and methods and then injects your object into wherever it needs to go. So injecting the methods and fields is kind of part of the construction. Yes.
I have a question. Can Juice does Juice supply provide the some functions about data persistence like Hibernate do?
No, Juice does not. Juice only implements dependency injection and a little method interception, but it integrates well with tools like Hibernate for data persistence. You know, it's like why reinvent the wheel? Hibernate's such a great framework. But if you join the Juice mailing list, there's discussions going on right now about the best way to integrate Hibernate with Juice. So like in Hibernate, you need access to a session object. Well, you can let Juice manage that session object, like create the session as needed and tear it down and then inject that session to wherever you need it.
Thank you.
Thank you.
have a question. Does Juice have a functional about after injector was created? Can I change the binding relationships?
He asked if you can change the binding after startup. Is that the question? No. As I said, I'm a big fan of immutability and maintainability. So with Juice, once you create your bindings, they're set. So if somebody comes along and maintains your code, they can tell exactly where that implementation is coming from. But that doesn't mean you can't do more dynamic things, like swap in a different implementation or do something like that. But if you want to do that, what you do is you write a custom provider, like I showed you. Like, because your custom provider can do whatever you want, right?
Does provider support the field injection?
So the providers are kind of separate from that. To the clients, they don't care whether you're letting Juice create the object or using a custom provider. It doesn't matter. Like, I always get service injected. So the providers are orthogonal to the way things get injected. Does that answer your question? Thank you.
I just wonder why Juice not use a script file to describe the relationships between the classes. For example, in struts, you use a XML file to describe to define the dependencies between classes. I think to use the XML file would be more flexible.
To use which? I'm sorry.
Like in struts, you use some XML files. XML.
Oh, so you think Juice should use XML?
Why don't you choose XML? Relationship with classes.
So he asked why Juice doesn't use XML. I don't have a problem with XML. I just haven't had time to implement a configuration for it. So Juice is an open source project. If somebody wants XML, then I'm more than happy to accept it. But actually, there is one roadblock to it. So for those of you that have used Java 5 with generic types, you know that they use angle brackets. And Juice has full support for generic types. So, which means I can inject list of user or list of integer, and Juice sees those as two separate bindings. And I don't know exactly how to express generic types with angle brackets inside XML, which already uses angle brackets. So.
Another question right on the paper, what's the relationship between Juice and Spring or WebWorks? If they were designed to solve the same problem for web development, what's the advantage of Juice over that?
Over Spring?
Spring or WebWorks?
Well, WebWork is a web development framework. That one's a little easier to answer. And actually Struts 2 is a successor to WebWork, if anybody's used that before. So if you like WebWork, I encourage you to try Struts 2, because that's effectively the next version. Compared to Spring, I started developing Juice over a year ago now. And we'd already had a couple years experience with Java 5 and we really liked it. And at the time, Spring didn't really have much support for it. I was developing a new piece of AdWords, and I asked myself, okay, so I stepped back and I said, how do I really want this code to look? How do I want to be writing this code? And well, after months and months of trying different things, Juice turned out to be the answer to that. Kind of the big difference for me, at least this was a bigger difference, was that this whole annotation approach, I just put @inject inside my class. Whereas with Spring, if you want to explicitly wire stuff, I have to have this kind of separate external XML, where I kind of have to keep it in parallel to my class and keep it in sync. And I have to repeat this information like the field name and method name. And it wasn't very good at handling multiple arguments. Like you'd have to use like indexes and stuff in the XML. But now since Juice came out, Spring has been adding a lot more support for annotations. But personally, I still prefer the simplicity and the speed and the reliability of Juice.
Hey, sorry I came late.
Oh no.
Yeah, I have a question. What's the Google's strategy in Juice project? Is there any Google's product use Juice structure?
Do any projects use Juice?
Yes.
Is that what the question is? Tons now. Actually, it's gotten very popular inside Google. As I said, it started off with AdWords and a couple other select projects, but now I've lost count of how many projects are taking advantage of Juice. It's you guys, if you write Java code, I really encourage you to try Juice. It kind of puts the joy back in writing Java code. And it's like those people over there at Guido, and then they talk about Python and all that stuff. Well, now that we don't have to write all those factories anymore, it kind of puts us on closer to the same level, right? Only less hacky. Sorry, Guido.
I want to. What's the major difference between the factory and the injector?
So you could look at the injector as a type of factory. He asked what the difference is between injector and a factory. It is a type of factory. I mean, you can ask it for objects and it creates them and gives them to you, right? The main difference is between, I think the real difference is whether you use Juice or whether you implement the factories by hand. So I kind of like, that's kind of why I started out with that example. I almost think of Juice as kind of a factory generator, right? You could do this same thing at compile time if you want to just kind of generate this factory code. But just Juice does it at runtime. Makes things a little simpler.
Can I say that the major difference between both of them is just method injection. Factory we can understand as is constructor injection. However, the inject is method injection.
What was that last part?
I mean that factor is only the constructor can be dynamic. However, in the injector, the method can also be dynamic.
Right.
Can I understand like that?
Yeah, I think that's a good description. Thank you.
Actually, I got another question, but actually it's asked the question about the config file, so I think you have the answer right.
Okay.
Another question?
I want to know why you name Juice. That's all.
What's the question? Or can you get the
Why it is named Juice?
So it was originally Juice with a J, right up until we open sourced it, but there were all these other open source projects that use that name already. So I just swapped the J in with a G for Google. And if you want the story behind Juice, I guess I can tell that. Rather not.
I have a question. At the runtime, the relationship is almost static. It will not change. So I have my question is that why I should use Juice? Because at the runtime, I didn't want to change the relationship. Or if I really want to change it, if I must give some more modules, and the modules, the relationship is from some configuration file, such as XML file or some others. If it does, so the annunciation and the XML file is all I used. So why don't all the XML files? That's all.
So you're asking, let me see if I can kind of rephrase your question. You're asking what using Juice buys you. It's like we're throwing away like a static model for a more dynamic model. Well, so I'm not sure I would call Juice 100% dynamic, because we still have a lot of static information. Like it's in my class, I see that client depends on service, right? And then I also pretty much statically know, or at least at startup, I could put some XML file and know it at compile time, what that implementation of service is. So I still know all this information statically, and I can still write IDE plugins that can kind of tell me that information. The main reasons for using it, well, you could write dependency injection by hand, as I showed you, The main reason for doing that would be, for doing that and using Juice is to make your classes more unit testable. And then the further reason for using something like Juice over that is just because you have to write a heck of a lot less code. I don't have to write like client factory and service factory. I just say one time, bind service to service impl. It's one line of code. And then I can use service over and over and over again. I don't have to write code to look up service everywhere, right? So that's the main thing. It makes unit testing really easy. You still get a good amount of static checking. Like I said, you don't have to wait until all the way into runtime to find out that something's missing. And in the case for using Juice is it just saves you a lot of coding and helps you do the right thing. Thank you. Any more questions? All right, I just want to thank you everybody for having me. This is my first time in China.